Hello guys, welcome to our physics class for today. In this particular class, we are going to be solving problems involving motion under gravity. Remember, we have treated motion under gravity already. So for this particular class, we are only going to solve problems. Then I will give you your test your understanding, which you will respond to. So guys, if you have not subscribed to this channel, please subscribe to the channel. Click on the notification button so that when we upload any new video, YouTube will notify you. This is Normal Science Tutors Online, and we are teaching physics online. You can reach us through the WhatsApp number that is showing right on your screen. Is that okay? So for this particular class, please get your writing materials, get your calculator, most especially your writing materials, so that you can follow through as we solve problems on motion under gravity. Is that okay? So let's go straight to the class for today. So this is our first question that we are taking under motion under gravity. The question says that a cricket ball is thrown vertically upwards with an initial velocity of 40 meters per second. Find its velocity after 3 seconds, maximum height, and the time to attain maximum height. 3. The total time of flight neglecting air resistance. Okay, so there are 3 questions that you need expected to answer from this particular question. 3 questions. So the first one is velocity after 3 seconds. The ball is thrown vertically upwards with an initial velocity of 40 meters per second. Okay, so the velocity after 3 seconds, the equation of motion that we use for this is the first equation of motion. Remember that you are given initial vertical velocity to be equal to 40 meters per second. This is what you are given, and don't forget that your g is always there constant, which is 10 meters per second squared. So your g is always there for you, 10 meters per second squared. Alright, so from the first equation of motion, now you are asked in the first question to find velocity after time. Okay, t is also given to you. Okay, t is 3 seconds. So you are asked to find velocity after 3 seconds, and that is what you don't know. So put a question mark there, you don't know that. Then in the second question, you are asked to find h mass. H mass, that is maximum height. Say h mass. H mass. Okay, then you are also asked to find the time to attain that. Time for each mass, you don't know, so we'll look for that too. And then the total time is capital T, total time of flight. So these are what you are going to be looking for in this particular equation: velocity after 3 seconds, maximum height, time of flight, time to attain maximum height, and then total time of flight neglecting air resistance. So from the first equation that we have, we had that v is equals to u, since the object is moving up, minus gt. Okay, so this is what we had. So from this equation, just substitute your values there. You have v is equals, u is equals to 30, u is given to you to be 40. That is 40 minus g is 10 times the time that is given to you. You are giving 3 seconds at 3 seconds. So you work this out. If you work this out, you are going to have 40 minus 30. 40 minus 30. So that will give you 10 meters per second. So that will give you 10 meters per second. 10 meters per second. Alright, so this is the velocity at time t. That's at time 3 seconds. That's the velocity at time 3. So that's the first part of that question. Okay, now you are now asked to find the maximum height attained. What you need to take note of is that at maximum height, you'll take note of the fact that at h mass, heat maximum, at h mass, v is equals to 0. So you need to take note of that. At h mass, v is equals to 0. Okay, so you are already given the initial velocity, so you can just for this one you are going to use the third equation of motion. Okay, that's v square is equals to u square minus 2gh. So your h is your h mass. So v is equals to 0 already, so that will be 0 squared is equals to u is 40, that is 40 squared minus 2 times 10, g is 10 times h. H is your h mass, that's what you are looking for. H mass, that is h maximum height. Okay, so if you work this out, you're going to have 40 squared is equals to 20 h mass, right? 20 h mass. So divide both sides by 20, the square, find the square of 40, right? If you find the square of 40, square of 40 is 1600. So divide by 20, then divide this side too by 20 to eliminate this. So when you divide that, you are going to have that h mass, this will cancel out. So when you cancel this out, you have 80. Okay, so this is your h mass, this is maximum height attained. So this is your maximum height attained. Okay, so you see how the equations are applied. Then the time to attain this maximum height is what now we're going to look for, right? From the equation that we derived before, t, we had that if you go back to the first lecture, we had that time to attain maximum height, t is equals to, since initial velocity, final velocity at maximum height is equals to 0, don't forget that at maximum height v is equals to 0. So which means that t to attain maximum height is equals to u over g. So substitute that into this equation. U is going to be 40 and g is 10. Okay, so that will give you 40 over 10. So your time to attain maximum height is 4 seconds. Okay, so there's the time to attain maximum height is 4 seconds. Alright, so the total time of flight, we say the total time of flight neglecting air resistance. So after attaining maximum height, the object will still have to come down. Okay, so from our equation that we saw, we had that total time of flight should be t is equals to 2t. That is 2 times the time to attain maximum height, because the time to attain maximum height is equals to the time to come down from that height to ground zero. So the 2 times are equal, so you just multiply it by 2, so that you have 2 times 4. that will give you 8 seconds. So this is equals to your total time of flight. Okay, so you can also find the time to come down from the maximum height to ground zero. If you don't want to go through this, if you don't want to use this method, right, you can also find that time there, add the two time together. This is the time to attain maximum height. Then the time from maximum height to ground zero, you can find it from the second equation of motion. Know that at maximum height, initial velocity is equal to zero. So from the second equation of motion, you have that h mass, which is maximum height, equals to ut. Now the object is coming down plus half gt squared. At maximum height, initial velocity is equals to 0, so this will be equals to 0. Since u is equals to 0, that becomes 0. So just substitute this value here. Maximum height is 80, so this will be 80 is equals to half g. G is 10, okay, times multiplied by t squared. Multiplied by t squared. So if you work this out, you are going to have that 80 is equals to 2 divided 10 is 5 t squared, right? So divide both sides by 5, you have 80 divided by 5. 80 divided by 5, so do that division till you have 16. So you see 80 divided by 5 all over 5 is equals to t squared. Okay, so 80 divided by 5 will give you 16. 16 is equals to t squared. Now you can square both sides so that t will be equals to square root 16. So square root 16 is equals to 4 seconds. So now the time from maximum height to the ground is 4 seconds. Time to attain maximum height is 4 seconds. So total t is equals to 4 plus 4, which is equals to 8 seconds. So you can see that you still have the same answer no matter the route that you take. Is that okay? So this is how to go through this type of problem. I hope this is a little bit simple and you follow the steps, you get to your answer readily. Okay, so this is another question. So that a stone is thrown vertically upwards with an initial velocity u meters per second. It reaches a maximum height and returns to the ground. Find an expression for 1. The maximum height, 2. Velocity on hitting the ground. Now take note of what you are given here. You are given that initial velocity u is given to you. Initial velocity u is u in meters per seconds. That's what is given to you. Or also know that your g is there. Your g is already there, it's always constant. Your g is always constant. But here you are saying that you should find an expression for initial maximum height and velocity on hitting the ground. So we should look at the equations of motion. If you look at all the equations of motion, the one that relates initial velocity and maximum height is the third equation of motion. Now know that at maximum height, final velocity is equals to 0, right? So if you know that, you will see that from the third equation of motion, v squared is equals to u squared minus 2gh. There's h mass. Okay, So v square is equals to 0 because at maximum height, final velocity is equals to 0. So that will now give you that. So with this equation now, you can rewrite this equation to be equals to u square is equals to 2 g h mass. So you are looking for expression for h mass. So you make h mass the subject of the formula. So h mass now will be equals to u square all over 2g. So this is the expression that you are looking for, and that is just the answer to the first question. That is the expression you are looking for. So h mass equals to u square all over 2g. Okay. Then for the second part of the equation, say velocity on hitting the ground. At maximum height, initial velocity is equals to 0. Okay. At maximum height, final velocity is equals to 0 and initial velocity is equals to 0. So it's still using the same equation. V squared is equals to u squared plus 2gh. Now at maximum height, initial velocity is equals to 0. Okay, so now you now have that v squared is equals to 2gh and v is equals to square root of 2gh. So this is the expression for the final velocity on hitting the ground. So this is the solution to this question. That okay? So this is the velocity of the object on hitting the ground. V is equals to 2gh. So these are the expression that the question requires. Okay, so this is how to go about solving this kind of problems. And this equation that we just derived now, we'll use them to solve other problems. Even in the test, you understand, you will still make use of them. So please take note of this equation that we just derived for maximum height and then velocity of hitting the ground. So let's go to another problem. So this is another question. Say calculate the maximum height a ball of mass 1.2 kg will attain if projected vertically upward with an initial velocity of 70 meters per second. So you see, this is just an application of the equation that we just derived. So this one, I don't need to waste much time. We got that h mass from that equation we derive. We said that h mass equals to what? It's equals to u squared all over 2g. That's what we had. So u here is given to you to be 17 meters per second. So just substituting to the equation, if you substitute to the equation, you are going to have that u squared is equals to 17 squared. That's 17 times 17 all over 2 times 10. Okay, so if you work that out very simply, your answer will just come out readily. So that way, if you work that out, you have 14.45 meters. See, so this one is very short and is direct to the point. No time to waste. So this how to use those equations that we just derived now. Please take note of them. Just take note and see how we use this equation to solve, right? So we'll do another one first, another one again. Fine, this is another question. An object falls freely from a height of 25 meters onto the roof of a building 5 meters high. Calculate the velocity with which the object strikes the roof. This one also is uses those equations that we just derived. Now for this particular object, see the height of the height of fall, the height h is 25 meters, right? You have to read your question properly. Then the height of the building, let me make that B, is equals to 5 meters. Now, if this is the height at which the object was released, and then it now fell into a building that is of height 5 meters, how many meters did the ball fall? It will be the difference between this height of the height from which the ball is released and the height of the roof of the building. So the height of fall of the object will be 25 minus 5. So you need to have this first before you can find the velocity with which it strikes the roof. So this is the height. This is the distance that the object traveled, or the height. That's okay. So from that equation that we derive, we got that velocity of hitting the ground is equals to what? Say it's equals to square root of 2 times g times h. So just substitute into this value, substitute these values into this equation. You have 2 times 10 times 20. Okay, so that would be square root of what? That would be square root of 400. So if you find that square root, you are going to have 20 meters per seconds. So this is the velocity, right? The velocity of striking the roof. So guys, you see how to apply the equations to solve any problem that you have. I want you to go back to that lecture, that video, watch it again, then solve all these problems that are here for you. Okay, so this is your test page. Please attempt all of them. As I've always said, you can solve them in a piece of paper, snap them, put them on the WhatsApp number that will be showing on your screen. Is that okay? I'll make my comments and then give you my own suggestions if your answers are not correct. Right? So this is where we are ending this class for today. If you have not subscribed to our channel, please subscribe to the channel. Click on the notification button so that when we upload any video, YouTube will notify you. This is Noble Mind Science Tutors Online. I remain Otubo Michael. Please reach us through this WhatsApp number that is on your screen. Invite your friends to come and enjoy this lecture that you are enjoying too. Please give us a like, give us a thumbs up, right? Okay. We promise to do our best to make physics as simple as possible for you. So thank you for your time. We'll see you in our next class.